0. That's actually going to have the same asymptotes as tan, because remember tangent was sine over cosine, so wasn't cosine on the bottom there as well. Okay, let's plug it in our calculators, and let's see what happens when we type in 1 over cosine of x. There's my window. Remember, I used negative 2 pi to 2 pi and scale of pi halves. And then what mode am I in? Radian. Okay. And so what basically happens, and this is kind of how it's related, remember if it's the reciprocal, do you guys remember how the highest and lowest sine and cosine got was 1? And so this is, if you flip those fractions, they become outside of that. So they do not, the secant graph and cosecant, they don't exist between negative 1 and 1. This lowest value here, this is a 1. And this highest value here, that's a negative 1. Just for the heck of it, you don't do this, but let me just graph it with cosine x so you can see. If I threw the cosine on there. Okay. All right, so really as far as graphing goes, they're kind of these U's. And so they're not technically parabolas or anything like that, but that's kind of how I remember it, as a U-shaped graph. So the parent equation is just y equals secant x. Because it's related to cosine, guess what its period is? 2 pi. Let's look at its range. Now its range is negative infinity to negative 1. And it's a bracket because this actually touches. And then what do you think this piece is? 1 to infinity. For the domain, this is not a lot of room to squeeze it in. Domain, I'm going to write same as tangent of tan x, but I'm going to go down here a second. The domain is going to be all reals except odd multiples of pi halves. But we wrote that in some different ways, like if you want to look on this sheet there, we did tangent. So if I wanted to write the asymptotes, I would write x equals pi halves, and then plus k times pi. And all this does is it tells you how to get the next one. So pi halves, and then the next one is 1 away, right? Because isn't 1 plus a half 1 1/2? And so that's the same as 3 halves. And so then the next one, I would add 1, it would be 5 halves. Isn't that an odd multiple of pi halves? Okay, so it's just a little formula. So the equation for asymptotes is pi halves plus k pi, where k is an integer. So let's just take a look then. Give me any 2 specific asymptotes then. Any 2, I don't care, if that's how I describe them. So it will be another one? Okay. Alright guys, so let's use our graph and use now what we wrote down, and let's put some asymptotes and sketch it. So here's my negative pi halves, and negative 3 pi halves. There's my asymptotes, right? And halfway in between each asymptote, I am going to make this U-shaped graph. So the first one's going to start in the middle, and I'm going to make it have maxes and mins of 1 and -1. And they alternate every time. This one, it looks like I only have half of the graph on there. Okay. So let's just talk about transformations for a second. I'm not going to write all of these things down. If I was writing a general equation for this, I could write A times secant, parentheses, B, x minus h plus k. I could write that. What do you think A would do to these u's? Yeah, I'm going to show you something. Okay, so let's say I wanted to do 2 secant x. The way I would put that in is instead of I do 2 divided by cosine x, I'm going to just quick show you what happens. The asymptotes aren't going to change, but you see now that those u's are stretched because they were at 1. 1 was the y-coordinate. 1 times 2 is 2. Okay. So that doesn't change the period at all. What changes the period? Which letter up there? B. And since it was 2 pi, the new period would be 2 pi over B. I am going to talk about the asymptotes again. So I'm going to take the old asymptotes and divide them by B. On your worksheet, I also asked you on a couple of them to, once you do that, I might have you shift them a little, but the graphing part, I want you to use your calculator to help you with that, and secant graph. All right, let's talk about cosecant for a minute or two. So, how am I going to graph cosecant? One divided by sine. Now, side note, guys. This is what the graph of secant looks like, correct? Sometimes people get confused because they think cosine to the -1 power on your calculator, that means this, but the cosine -1 here doesn't mean to the -1 power, it means the inverse function, which is something different. I want to just quick show you, if you would type this in on your calculator, you get a completely different graph. This is the original. Here it comes. See that little line in the middle? So don't graph that, you're going to get really confused. You have to type in 1 over cosine, okay? All right, let's do 1 over sine and see what changes. First of all, where do you think the asymptotes are going to be? Same as cotangent? Yeah, so odd multiples of pi. Not even odd multiples, all multiples of pi. The period is 2 pi. And it's going to look pretty close to the same. what's different from above? It's just shifted over, which, think about it, isn't cosine shifted over from sine? Same thing, because they're reciprocal. So the range is going to be the same. For your equations for asymptotes, we're going to write x equals k times pi, because there's one at 0, pi, 2 pi, every single integer multiple is pi, where k is an integer. Maybe two specific asymptotes could be 0 and pi. And then let's go ahead and put some asymptotes on there and sketch it. Okay, so last couple things. I'm not going to talk about A, because really the same thing applies as before. If you change A, really it's the only thing that you're going to noticeably see change on the graph is where the max and min are, because what it does is it's going to stretch or shrink those things. But if you change B, what would that do? That would shrink it, so it could change the period, right? So I'm going to change then, same deal as before. The period is 2 pi over absolute value of B. And to find new asymptotes, you're going to take old asymptotes and divide them by B. And again, that would be with no horizontal shift going on.